Hello student, today we will discuss about cell and tube heat exchanger. So basically why we use cell and tube heat exchanger, it is generally used for heat exchange between two fluids when your two fluids will remain in indirect contact. So what happened? This is a schematic diagram of cell and tube heat exchanger. It is a cell, this portion is a cell, this is tubes, your tubes, which is fixed with the help of this tube sheet. This is a tube sheet. And here some baffles for support of tubes. The purpose of baffles is to support the tubes and to create the turbulence. So suppose here this is a diagram of counter current. So one fluid moves in opposite direction, one fluid in this direction and one in this. So two fluids move in opposite direction. It is a counter current flow. When parallel flow, what it means? When your two fluids will flow in same direction. It is a parallel flow. It is a parallel flow. It is a counter current flow. Counter current current flow. Okay. So suppose your hot fluid is entering in cell from one side and by moving through cell it is just out from another end. It is at temperature TH2. So always remember TH1 always be greater than TH2. Why? Because here it is your cold fluid will enter the tube. This fluid will flow in tube. This is a cold fluid. Your cold fluid TC1 having temperature TC1 and it will move through this tubes and will come out from this other side TC2. So it is a counter current flow. Your cold fluid moving in one direction and your hot fluid moving in opposite direction. So it is the process of your tube heat cell and tube heat exchanger. So basically your tube in a process industry which is made of material of steel, because if you will make in some industry we can also use iron, but it is a preferable to use tube of material of steel material. If you use steel material, then the chances of corrosion will very less. So you will not replace the tube or heat exchanger after some time. Otherwise, if you will, if your fluid is corrosive and you are using iron, then it will corrode. So you have to replace the tubes after some time. You will have to replace tubes after some time or your heat exchanger. So it is a tube sheet. It's your header. It's your header. It's your cell. So that's why it is called cell and tube heat exchanger. Okay. So generally we use one type cell and tube heat exchanger. What is one? It is a pass. It is a pass. What the meaning of pass? Because here in this diagram you can see the cell, the fluid which is moving in cell side having only one pass. Only one pass. So one pass it just moves out from this heat exchanger and your fluid, another fluid which is moving inside the tube will moving towards outside through one pass only. Okay. So it is a one pass. It is a cell pass. It is a tube pass. Suppose now, suppose now change the diagram. Let's just change diagram. If we block this, if you block this and we remove this and we enter your fluid from this side TC1 and just block this side, then your fluid will move through this side, and suppose this side we will remove. Okay, so what will happen? The cold fluid will enter. This side is blocked, so this will move in these tubes, and it will come in this section and then now move this side. So one pass, the liquid will moving through this one pass and then through this pass. Then you can say in tube there is a two pass. One pass moving towards this side and now this side. So it is diagram of 1-2 heat exchanger. 1-2. One is cell side pass and two is tube side pass. So it is 1-2 pass. Okay. Now come to the same situation. 1-1 heat exchanger. It is a 1-1 now. It is a 1-1 heat exchanger. Okay. So in industry generally we use 1-1 and 1-2 type heat exchanger. Also you can use 2-4 type heat exchanger. 2-4 heat exchanger in which the pass will be 4 tube pass and 2 cell pass. How it will become 2? So if you want to 2 pass, then you have to longitudinal baffles. It is a, you have to insert baffle like this. So the fluid will block the passage of cell side fluid and it will move this direction, and you have to the fluid will now come come out from this side. Okay. So it is just example for your sake of understanding. Okay. So now come to the same situation. It is a 1-1 heat exchanger. So in 1-1 heat exchanger and in counter current flow, this is just schematic diagram of graph T1 and T2, how it according to length. In x axis it is a length, in a y axis it is a temperature. Suppose hard fluid TH1, it is a hard fluid TH1 enter and its temperature down towards another end TH2, like TH1 and TH2, and your cold fluid enter in this side TC1 having at one end temperature TC1 and other end TC2. Okay, so you will get the graph up like this in a counter current case. If the case your suppose your fluid moving in the same direction, like now suppose this direction, then it becomes TC2 and it becomes TC1. Change the direction, so the direction of both the fluid will be same. So it is a parallel flow. So in parallel flow condition, we get graph like this. Okay, TH1, TH1, TS2, TS2, TC1, TC1, TC2, TC2. Okay, so we get the graph like this. Good. Now TC2. Okay. So in generally cell and tube heat exchanger, your tubes, this is a tube size, it remain 0.5 inch to 0.5 inch to 5.5 inch to 1 inch generally, which we use in a chemical process industry. The tube size remain 0.5 inch to 1 inch. Okay, and your cell diameter remains like a 8 inch, 7 to 8 inch or 9 inch. So generally, interviewer can ask the question. So what is the tube size, which is generally in a chemical industry, which we use? So it is a 0.5 inch to 1 inch. Now we talk about the arrangement. So you can arrange by two manners. First is like this tube. It is a square arrangement. If you will use this arrangement, so it is a triangular arrangement. Okay, you can take the tube in tube sheet by two arrangement. It is a square arrangement, it is a triangular arrangement. So for the same area, the tube number of tube will be more in triangular arrangement will be more. So heat transfer in triangular arrangement will be more. Okay, in compared to your square arrangement. Okay, so sometimes they ask about the what is the pitch, the center to center distance between two adjacent tube is known as pitch. Center to center, it is a pitch. Suppose this center to center distance, it is a pitch. And another term comes clearance. So from the surface of one tube to another surface of one tube, the distance between two surfaces is known as clearance. It is a clearance. Okay. So generally in interview they ask the question, what is pitch, what is clearance, what is the relation between your pitch and clearance. So what will be the relation? Clearance, what is the relation in clearance and pitch? So suppose clearance or pitch is equal to clearance plus diameter. Why? Because this and this center distance r plus r is equal to 2r and it become dia. 2r is equal to dia. So pitch is equal to clearance plus dia. Okay. Okay. Now come to the part of its heat transfer. So how you will calculate the heat transfer? So the simple formula of heat transfer is Q is equal to UA delta Tm. What is U? U is the overall heat transfer coefficient having unit var per meter into Kelvin. A is equal to heat transfer area meter square. Delta Tm, what is delta Tm? Logarithmic mean temperature difference. It is nothing but delta T2 minus delta T1 ln divided by ln into delta T2 by delta T1. What is delta 2, delta T1, delta T2 and delta T1? It is nothing but at one end the temperature difference at one end of heat exchanger and the temperature difference of another end of heat exchanger. It is delta T2, it is delta T1. It is a one end of, it is a temperature difference of hot and cold fluid at one end, and it is a temperature difference of the same fluid at another end. It is a delta T2 minus delta T1. Okay. So by this you can calculate the heat transfer area which is you required. And how you will calculate Q? So suppose simple formula is Q is equal to mc delta T. M, the flow rate of the hot fluid or a cold fluid, you can take anything. C, heat capacity, specific heat capacity, delta T, difference between same fluid at both the end. What is the difference? Suppose in case of cold fluid, Tc1 minus Tc2, it will be delta T. In case of hot fluid, it will be Th1 minus Th2. Okay. So by with this formula, you can calculate your heat load and put this value here. and with the help of this you can calculate heat transfer area required. If your overall heat transfer is given, then you can calculate by this way. So it is the superficial touch about this topic. In the next video we will get in deep. Okay, suppose uh okay, okay, hope this is clear all of you.